Francesco De Rosa, please. Francesco De Rosa will present cybersecurity and functional safety challenges in the development of infotainment systems, commonalities and differences. A few words about Francesco. He's head of functional and safety and cybersecurity group at the ART and site manager at the ART in Germany. He is an electronic engineer who later specialized in embedded systems. He has several years of experience as a functional safety manager and assessor in the automotive, machinery, and railway sectors. And is also in the Italian committee for deciding the ISO standards. So, thank you.
Thanks for the kindly presentation. So, today my speech is related to the functional safety and cybersecurity with the focus on automotive sector and with specialized discussion about the common point differences, because that two disciplines have some points that are in contact, but some differences that it's important to know to analyze in the better way the two disciplines. Before that I go in deep detail about the speech, let me present my company, ART. ART is a tier 1 company in headquarters. It's in the picture and is in Passignano sul Trasimeno. It's in a very beautiful town near the lake. And this is not the town, this is our plant, it's our headquarters, where we cover all the phases of our products, starting from the definition of requirement to the manufacturing. Here we have also the plant. And we are tier 1 in the infotainment system, and we have the leading of infotainment system for luxury and sport vehicle. The mission I already mentioned is our technology product, and we cover our mission with our value that reported in that slide, that are respect for colleagues, for environmental, for customer, for legislation, responsibility in what we do, that is one important pillar of our activity, and passion. Of course, to implement a high-level technology and high-level competencies like functional safety and cybersecurity is very, very important to do what we do with passion. And here there is ART Germany, that is 100% under control of ART Italy, is a subsidiary of ART Italy, that is a competence center for functional safety and cybersecurity. We use this business model. In that way we can have let me say best trade-off between the knowledge of the product and also the development of product, all the phases of the product, but we have with a separate competence center, we can grow up the competence, and also we can be independent in the participation of working group and internal assessment, and also by providing support for external partners. Now, let's me to move in the what is functional safety and what is cybersecurity. I'd like to start with the definition, because in the definition then there is the main message of what are the difference. Functional safety is defined for automotive as absence of a reasonable risk due to an hazard caused by internal failure. So we have the internal failure, fault or failure, due to hardware, software, wrong requirement that can have an effect. This effect can have a dangerous hazard, and these functional safety are all the activities, process and technical activities that have to be put in place to avoid that this fault or failure created the hazard. From other side, we have the cybersecurity that is defined like the condition in which the assets are sufficiently protected against a threat scenario, external attack. What we can see in this definition, that in both definition there is the concept of risk. In one case, the risk is strictly defined. In other case, it's called sufficiently protected. But in both the cases, the two disciplines are correlated to the risk management. And this is very important, because this means that the functional safety and cybersecurity can have an effect that can be tangible, not a short term, but a long, medium term. This means that for both it's very, very important to have a robust process, not a bureaucratic process, but a robust process to put in place the activities, and also a very established culture to be sure that the two activities are performed. Then moving on to the differences. Here I reported how the functional safety and cybersecurity are in contact with homologation requirement and liability state of the art. The main difference is that cybersecurity today is a legal requirement for the automotive car that we put on the market, and the ECR R155 is the standard that the legislation that is applicable for cybersecurity. Functional safety, up to current legislation, is not an homologative requirement, so there is no legislation mandatory requirement to apply the functional safety to put the car in the market, and this is something, the trend that it will be applied in the next year. There is for my knowledge, there is no any trend to have the functional safety as a legal requirement. Bots have a standard that defines the state of the art, 21438 for cybersecurity, 26262 for functional safety. That is the state of the art that has to be applied, and the OEM and the supplier, the tier, have to demonstrate that they applied in case of accident, with cybersecurity impact on functional safety. So the commonalities that the bots have an ISO standard for liability. The difference is that the cybersecurity is a homologation requirement. I said before in the first slide that both the discipline are based on the risk assessment, on the management of the risk. And here it's an important slide from my perspective, where we calculate the risk for functional safety and cyber. It's calculated with a different parameter, but at the end the method is the same. We have in one part the impact. Functional safety impact is only the severity. So how much can impact the hazard if the hazard happen? Can be no significant failure for the person, for the driver, for example, or a significant failure like the death of the person. And then we have the probability that the feasibility of the failure happen. In terms of controllability exposure, the controllability is the possibility of the person, of the driver, for example, to avoid that the hazard happen in case of failure. Exposure is the percentage of the time where the system that we are analyzing is exposed to the hazard if the failure happen. By combining the three parameters, we have the HASIL that represents the safety level of our function that can go from A to D. A means the lowest value, D means the highest level. The risk assessment for the cyber is a bit different, but not so much. We see first point that we have 4 parameters that can have an impact. One parameter is the safety. So there is a first point of contact. The safety can be considered in terms of risk assessment a subset of the cybersecurity. And then we have also financial, that is considered operational, and privacy. So we have different elements that are considered in the impact. Another important difference are the elements that are considered for the probability or feasibility of the attack. We have equipment, we have expertise of the attacker, window of opportunity, that is the window of time that the attack can happen, and also knowledge of the item. Here we see a very big difference between functional safety and cybersecurity. The risk assessment of the functional safety is performed at vehicle level, at system level, without taking into consideration the system that we are analyzing, without hardware, software, and technical detail. The cybersecurity risk assessment is performed by considering the specific item, and so that means that it's performed more at the low level. But there is also another tricky difference, or another tricky case that I reported in this slide. It can happen that a system that has a high level of impact for the severity, for example, fatal injury, by combining the controllability exposure parameter, that because it's very simple to control the effect, it is very low probable that this scenario happen, it will be QM. QM means that the function is not considered safety relevant, is not in the safety context. For the same, it can happen due to the fact that the safety will be severe. Also, if we have a low attack feasibility rating, the risk value will be 3. And so this is very important when we consider it in the same context, functional safety and cybersecurity, because I hear a lot of time that we have a system that is not safety relevant, it's a QM system, and so this means that don't care the cyber about the safety impact. This is not true. may be true with some consideration, but this is something that we have to put very, very attention, because this is one of the main points where there are some risk in the analysis. Moving forward in the process. The process is exactly the same in terms of concept, the same phases. We start from item definition, that is the definition of the system, of the function that we are going to analyze. Then we have the risk assessment for the functional safety is called HARA, and then we have the TARA for the cybersecurity. Then we have the definition of the goal, that high-level requirement, the concept. Then they have the implementation of hardware-software requirement, and then we have the validation phase, the right phase of the cycle, that it's the validation and verification activities. Again, here we can see some differences in the not specific in the phases that I say again that are more or less equivalent, but in the allocation of activities between OEM and Tier 1. OEM, we say that functional safety, the risk assessment is performed at vehicle level, at functional level, without considering the specific component. So that means that the HARA and also the safety goal and functional safety concept, the high-level activities are more in the context of OEM, not in the supplier. Supplier receive as input that information. This is not possible, not fully possible for the cybersecurity. The TARA, so the risk assessment for cybersecurity, shall be performed both from supplier and from OEM, or at least shall be shared, because they have a different perspective and they can identify different hazard, cybersecurity faults from both. Another important difference is the continual monitoring. Continual monitoring is a specific activity of the cybersecurity. This is important difference. Basically, when the validation is closed for functional safety, we can say that for functional safety, 99% of the work is done. Of course, there is a part of activity that is production, operation, service, and decommissioning, but is a very, very residual part for the functional safety. For cybersecurity, I will say that start an important part of the activities, because our product will be on field, and it is the moment where the attack can perform its attack and can try to have his evidence of his job. So it's very, very important to continue to monitor how much is cyber relevant is our product, and if there are new vulnerability that can have an impact on our product. So in other words, the functional safety, the main activities are closed with safety validation. The activities of cybersecurity continue for all the life cycle of the component, also when the component is on the field, on the car. Now some example about how the functional safety and the cybersecurity can be in overlap. One of the important challenge is that functional safety, by definition, the functional safety measures can impact on the cybersecurity. Let me to do an example. The functional safety in terms of management of the failure is quite simple, quite from bracket, of course. If we have a failure that is dangerous, we have to reach a safe state. Safe state for a car can be put the car in a standstill condition. This is good for the functional safety, is less good for cybersecurity, because this, and also for availability, because this has an impact on the operational. So this is an example where the functional safety safe state has an impact on cybersecurity, in a specific case on the operational. How we can manage this? Of course, the two disciplines in that case are in contrast. How we can analyze this? It's important that a possible solution is that a common review between functional safety and cybersecurity is performed. In particular, it can be analyzed, and we perform this, for example, if there are conflict requirements between the two areas. And the other one is to evaluate the risk assessment of cyber and functional safety by considering the two concepts. But there are also some common point that can be used to increase to have some advantage, to have more efficiency. For example, some measure can be useful to mitigate both safety and secure risk. For example, secure communication mechanism is an example. In this way, with a common team that has a double point of view, we can have some efficiency in the process, because in this way, we can use a common validation and analysis, and a double check of the requirement, or with a single check, we can analyze both the cases. Moving now on what are the specific activities that are for functional safety and cybersecurity. Let me to open a parenthesis. The standard of functional safety, the first version was released in 2011 or 2010. The standard of cybersecurity has been released in last 4 years. So for this reason, there are some differences also in the needs. One important need, unfortunately, for the functional safety, I will say that it's the functional safety required to have some metric on the hardware. On the hardware, our hardware has to respect some target for reliability and for the percentage of fault that are detected. This has a sense. It makes sense because if you remember the definition, the functional safety is based on the correct management of internal failure and fault. For this reason, it's important that our product has a certain level of availability. From other side, the cybersecurity, as I mentioned before, is required to perform the continual monitoring after the production of our system. Let's move on to conclusion and to recap what the main concept the pillar that I shared with you today. The commonalities, both the discipline require a robust process and a established culture, because it's very important that there is a culture, because it's an intangible activities, bots, so the effects are at medium and long term. So without a robust process, not bureaucratic process, but robust process, it is not simple to have evident effect. Cybersecurity is an homologation requirement, non-functional safety, and it's important to highlight that non-functional safety system may be cyber-relevant system, and overlap between functional safety and cybersecurity can create interference, especially the functional safety can have an effect on the cybersecurity. The strengths between the two, especially if we have a common team like us, is that we can perform some activities with the double perspective, and this can create efficiency and can create also some validation activities that are performed with some effectiveness. And the cooperation between functional safety and cybersecurity, due to the fact that the background is the same, can be very helpful to grow the culture of the company and also the company and of the stakeholder for the implementation of the two disciplines, functional safety and cyber. Thanks.
Thank you, Francesco. Is there's some? Okay.
Hello, it's Manuel Crotti from Security Pattern. It's a cybersecurity company from the north of Italy. My question is, you mentioned continuous monitoring, and it's a trend that nowadays is expanding through automotive, but also industrial automation and control system to comply with the CRA and RED directives, I suppose. How do you think to perform or implement the continuous monitoring on your solution?
Okay, we implement in a simple way, I would say, or better, the solution is simple, the application of the solution required a lot of internal activity. So we have our product, that we have the BOMVO material that is finalized, and with a tool we know what are the vulnerability, the new vulnerability that can be that are applicable, I will say, day by day. We analyze the vulnerability week by week, and in the case where identify a new vulnerability that was not known when we released the component, we perform a risk assessment. We reuse the TARA that was performed at the beginning of the project to evaluate if there is a new risk, if the risk can be managed. Then we have a check with our customer to identify the solution path and the planning, because of course there are two options. the vulnerability can be accepted because the risk has not an effect. The vulnerability can require a new software version, but that we will use the new software version only for the new products, because we have some products that are on the road and it's not needed, it's not mandatory to update. Third case, now we know that especially for automotive, it's possible to update the software with OTA. We can also update the software with the OTA, with the software that is on field. So we have the three scenarios. The risk, of course, we perform the risk assessment, and based on the risk assessment, we take the best decision together with the other stakeholder, customer or the other stakeholder.
Hello, Federico Vigna from ZF. I'm generally working on vehicle dynamics side, so I'm not a cybersecurity expert, but I'm definitely involved, let's say, in cybersecurity challenges when developing new components, working with car makers. The consumer experience of cybersecurity is generally with computers and mobile phones at the moment, and now it is with cars. It's easy to get rid of an old mobile phone or an old computer, because generally when it starts to be unsecure, generally all the apps in that phone becomes unusable. And so it's easy that, for example, very popular applications like Netflix, WhatsApp, etc., stop working because they are unsupported on your device. But with the lifespan of a vehicle that lasts also 20 years, will there be an expiration date on such kind of commodity? Because I expect that with sufficient time and technology progress, all the vehicles will become unsecure, and the effort to keep the security of the vehicles will be so high that that it's not worth to continue fixing all the vulnerabilities. So
if I understood that I keep your question, you are asking if there will be a moment, a certain time where all the vehicle will be a certain level of security. Is this or?
Yeah, as a vehicle already released becomes older and older and older, it will be difficult to, let's say,
Okay. Yeah. Okay. I think that this is of course, my personal opinion, that we can see the cybersecurity for the vehicle that we have on the road exactly in the same way for the other, regulation or the other things that we have for the vehicle on the road. Let me to explain in a different way. We have a emission of the vehicle. The rule for the emission are applicable for the new vehicle, not for the vehicle that have been developed in the field, but also we have some legislation, some law in the city that are in contracts with the Euro 1, 2, and 3. So in this way, the legislation, let me say, accelerate the removing this car from the market. From the road in simple way. And the other thing is the technology, the cybersecurity. Now it's not something that it's perceived by the final customer. Of course, he has not the sufficient knowledge to understand if the vehicle is sufficient secure or not secure. But like other things, if you think, for example, at some other ABS or other equipment, now someone that not have this type of equipment, like infotainment itself, in some cases the person change their car because the infotainment that they have is very old and they want a new infotainment, not because this is an example. So just to come back on your answer, I don't have a precise answer to your question, but I think that cybersecurity will be one of the trends to accelerate the introduction of the new car that have this feature implemented in the market. Will be another trend because the car has more and more cybersecurity items, element in the car itself. The car are connected, so cybersecurity will be more and more relevant, and this will be something that accelerated the transition.
Okay, thank you again, Francesco. We have no time for further questions today, so let's leave room for the next session. Thank you again.